So, as promised, here's the video, full video, 40 odd minutes of our trip out, well, hardly out, our small journey in Cuttys Fish Seeker. The Fish Seeker, of course, is a glass-bottomed affair. You can also hire yourself a glass-bottom kayak and paddle around by yourself. Maybe not when you're by yourself. Look, I take video to a whole new level of lowness here, and I wouldn't put this up except I found Manny the Californian marine ecologist dialogue quite fascinating. Most won't, but I did, or we both did. Particularly interesting, I thought, was how the female mates with several males, collects the male's genetic packets of genetic material, and then decides later which genetic material she'll use to fertilise the eggs. Quite advanced, I would have thought. Anyway, there's a few cuttlefish, there's a ray, and some human refuse. This, of course, is right next door to the big Santos plant and jetty, and Santos is a sponsor as well. Of course, we're going out looking for cuttlefish. Not this big blue bastard here, of course. He sits back in Whaler. So get yourself that cup of tea, some type of biscuit coming from South Australia. Of course, the yo-yo biscuit. Or perhaps you could step out and have an orange cream or a Monte Carlo with your cup of tea. Again, don't expect anyone to watch, but the dialogue's pretty good. There's a lot to learn. Well, for me anyway. Good experience. Not real expensive. We enjoyed it anyway.
Alrighty guys, so guys, welcome aboard the Fish Seeker. My name is Manny, thanks for your cooperation. Today we're here for the giant Australian cuttlefish. So what's the deal? Do you guys know? Why are the cuttlefish here? Yeah, sexy times. Yes, they do. I'll get more into that later. I'll go into why that's the case. But yeah, they come here to reproduce, carry on their genetic lines. The mothers, they'll glue their eggs to the underside of the rocks in nice, dark, protected spaces. So the rocks, they provide protection from predators as well as from harsh environmental conditions during the winter. And also during the summertime. During the winter, we have predominant offshore winds, and during summertime, it's predominantly on. Now, these stones, they also play another really important aspect. When we look below us, what do we see? In the waters of the upper spectacle, it's like a tea kettle with a little bit of water. This is a shallow body of water. It's almost like an estuary. So it's a really dynamic ecosystem. Changes a lot. And during the summertime, when it's warm, the cuttlefish, they don't like to hang out. They leave. As spring quickly approaches, some of these cuttlefish will migrate out. All the babies will leave at some point. And they'll go to waters that stay nice and cool. So they'll go further down south and waters further into the Spencer Gulf. Now, where do they go exactly when they leave? We don't know. But did you see that girl in the waders up there? Yes. Her name is Bethany Jackal. She's doing her PhD. She's from entertaining. She's doing her PhD on the migrational dynamics of the upper Spencer Gulf cuttlefish. Trying to figure out where they go. So, hopefully, she'll give us the answer in the next few years. Now, I just said upper Spencer Gulf cuttlefish. Why did I say that? Well, these cuttlefish. I do apologize, I can't stop the boat. The wind is blowing us, and because of these shade cloths, it sort of acts like a sailboat. It's like a brig with sails, basically. I'll try to get us over a good grouping of them.
So how big of a bite when they hatch?
Oh, that's a great question. So when they're first laid, they're about this big, about the size of a 50-cent piece. And then once they grow and develop, they turn into the size of a large avocado seed. About that big, so they're pretty small. But it's amazing because this is the largest cuttlefish species on the planet. These guys can grow up to about 1 meter in length, weighing up to almost 5 kilograms. Pretty big. So all of them. So all of the giant Australian cuttlefish. Yes, all of them. Well, specifically the males. The females, they do not get that big. Only the males. The females only get around half that size. That's a good bunch of them. Good bunch over there. I'm gonna reposition us a little bit. Asking all these really amazing questions that I'm gonna answer by the end. I'll have all of your questions and more answered by the end of the tour. We'll open up the room for Q&As near the end. Now, guys, these cuttlefish, they're pretty stunning, very beautiful creatures. You can see that they've got different colors and patterns on their backs, along their carapace. But why do they have different colors? Why do they display different patterns? Why are they exhibiting the behaviors that we are seeing today? Well, really to understand these behaviors, to understand why they do certain things, we have to understand how they do it. So guys, these cuttlefish, they have a few different types of skin cells that allow them to change their colors. And the first one we're going to talk about today is what's known as a chromatophore. Now the chromatophore is a pigment cell. And the chromatophore, what they can do is they can contract the muscles around their chromatophore. They can squeeze their pigment cells and it spreads it across their bodies. Now, the chromatophores are the reds, the browns, the yellows, the purples. So those darker and primary colors, those are all created by the chromatophores. Now, just underneath the chromatophores, they have what are known as iridophores. And the iridophores are not a pigment. They're actually sort of like a prism. They're a light bending cell. And they can take ambient light and refract it. It creates those iridescent blues and greens. So you see the iridescent blues and greens in the edges there? Those are created by the iridophores. Then just underneath the chromatophores and iridophores, they have what are known as leucophores. And the leucophores are a base skin cell. I like to think of this as the canvas of a painting, that the other skin cells are stacked on top. And they'll use their skin cells for a variety of purposes. But like this gentleman over here I mentioned, yes, the primary purpose for this is camouflage. To hide from predators. They can use their skin cells to blend into the environment. Now, why would they, they're going to be hiding from predators, they're going to camouflage. So what are they going to be hiding from? Does anybody have any guesses?
Squid jigs.
So they're not hiding from humans, but what are their natural predators? We are not their natural predators. Dolphins. Yes, cetaceans, sharks. So certain shark species like Port Jackson sharks, bottom-feeding sharks, not great whites, not bronzies. Those sort of sharks don't go for them. But what else? What are the natural predators do they have? So the rays don't go for them really. They sort of just hang out. The rays are going mostly for like crustaceans. Seals, yes. So seals and sea lions are the primary predators in this area. So the long-nosed fur seals, as well as the Australian sea lions, like to eat them. As well as fish. So certain fish species like snapper and yellow-tailed kingfish eat them. And those species actually utilize this habitat as nursery site, as a reproductive zone during the warmer months of the year. So when the cuttlefish leave, those other fish species come here and reproduce. Now, aside from hiding from predators, what is a good use for camouflage? Hunting, right? These guys are ambush predators. You can see they're pretty slow going, right? So they require the element of surprise to be able to sneak up on their prey. And in fact, they are what are known as a Class 3 ambush predator. Now, what does this mean? Well, we've just established they're not the top dogs of the food chain, but they're not at the bottom either, sort of in the middle. So what do these guys like to eat? What are they hunting?
Crabs, prawns.
So prawns, crabs, so crustaceans, absolutely. When they're really small, when they're this big, right? They like to eat these things called amphipods. And amphipods are snapping shrimp and brine shrimp. Really small, tiny guys, like krill. Then they'll move on to these things called isopods and copepods. Isopods and copepods, they're sort of like the cockroaches of the sea. Little bugs that hop around. Ooh, kind of squirmy, kind of gross. Then once they get a little bit bigger, they'll move on to these things called gastropods. Anybody take a stab at what a gastropod is? Snail. Sea snails. So sea slugs and sea snails they like to eat. Then once they get bigger, they'll go for the crabs and the prawns. So what's the common theme between all these different animals that they like to eat? all shellfish. So, and all these things that have hard shells on the outside with a bit of meat in the middle. So how do the cuttlefish get through these hard shells? Well, they have what are known as a beak. So just at the base of their tentacles, it's just like a bird's beak. Squid and octopus do also have them. So what they'll do is they'll use their beak. It's a hard, drill-like structure made out of calcium. And they need to use to pierce the shells of their prey and suck out the meat. Now, once they get a little bit bigger, they will eat fish. And so cuttlefish, they'll start with the gobies, the small guys, and then they'll move up. And cuttlefish, they actually do eat snapper. So cuttlefish eat snapper, snapper eat cuttlefish. It goes both ways. Kind of depends on whoever's bigger on the end. And that's one of the big reasons why we don't see many other fish species hanging around. It seems like it's pretty barren down here, right? It's because those other fish know, the snapper, they know that there will be anywhere from 1 to 200,000 of these class 3 ambush predators. So they get lost, make themselves scarce. Because while they're here, they are not eating you. They are starving themselves. Why would they be doing that? Well, they're laser focused on the behaviors that we're seeing today. It's reproductive behavior, mating rituals. So can anybody guess as to what the most common behavior that we see today is? For what purpose? Peacocking. These guys, most of the ones we're seeing today, these are males. The females, they're underneath the rocks. Or underneath the males. But these males, the ones that are roaming out and about that we see, they're peacocking, right? They're putting on a bright display of contrasting colors. They're easily visible, right? They're not camouflaged. They're trying to be seen. So they're going to try to put on the best display of colors that they possibly can to try to get a lady friends. And so we see lots of peacocking, but what we also see is lots of posturing. So the second most common behavior is posturing. What is posturing? Well, when you see the cuttlefish do this, where they sort of butt up against each other, they might even be sort of tip to tail. You got when they're butting up against each other like that, no, they do not love each other. It's them squaring up, getting ready to get into a bash-up. Okay? And they're doing this because a male and a female have already mated. And one of the males is trying to prevent the other one from mating with her. He's trying to ensure that his genetics get passed on. And so this posturing, what they're doing is you will see them when they're posturing, look at their backs, because oftentimes they'll be doing what's called strobing. So they'll be flashing their chromatophores across their bodies. They'll actually be changing color in real time. And so when they're doing this, they're saying, get away, back off, fine, and they're also sizing each other up. So they have really well-developed eyes, just like our eyes. It's a little bit different, but pretty much the same. And they're sizing each other up. They're trying to figure out who is bigger, you or me. And the small ones generally will back off. The small ones can't physically compete with the big males. Looks like a... down there, you know? So the small ones can't physically compete with the big ones, and oftentimes they don't like to get into fights. So you see these two posturing each other. You can see them strobing a bit. Nice. There it is. And so what's going to happen there is the small one is going to back off. Can't fight the bigger one. Remember, they're starving themselves, and so they want to conserve as much energy as possible. And so if this is the case, the small one backs off and the big ones always win. How do the small males, the short kings I like to call them, how do they get any action?
Next year.
No. They only live to be 12 to 18 months old. They have an incredibly short lifespan, so they don't get another chance. This is their one shot for glory. Okay? They literally go out with a bang. tend to be, no, they actually have to be funnier than the big males. The small ones, they have to be more charming, have better personalities. Yeah. But no, in fact, you're absolutely correct. So the small ones, who aren't as big as the larger males, the small ones who are roughly the size of a small female, will dress themselves up to look like a lady. Rather than putting on a bright display of colors, they'll oftentimes display more of a camouflage pattern. And then what they'll do is they'll wait. They'll wait for the perfect time to strike. They'll wait for those big males to be distracted. And then once that big male is distracted, warding off predators, these small males, we call them sneaker males. They'll sneak underneath the big ones and quickly mate with the female that's under the rocks. Yeah, the sneaker males, that's a scientific name for them. I'm sure we all know somebody a bit like that. Yeah. Now guys, this type of behavior, this sneaking behavior that we're discussing, we don't know of any animal in the animal kingdom that does this. It's really quite something, except for maybe footy players. Yeah. Now, this behavior, we can't actually see it from close because you have to be in the water observing them for a pretty long period of time. Like you have to be with them for 20, 30 minutes to really see what's going on. So we don't see lots of sneaking, but we see lots of peacocking, we see lots of posturing. And then the third most common behavior that we do actually see on the boat is mating. So there's a chance we can see some mating today, if we have lucky to see it. And so what does mating look like? Well, it looks like this. So they go tentacles to tentacles, right? They go face to face, they interlock. The males will have his tentacles over the females. Now, I'm not gonna get too graphic. Big boys down there? So these males, they have a specialized tentacle. It's called the hectocotylus. Okay? What they'll do is they will use their hectocotylus to transfer packets of genetic information onto the females. You gotta keep PG for the kids. There should be a couple over here. Big boys. Now, these ladies, they do not fertilize their eggs just yet. What do? Well, they'll go off and they'll mate with a handful of other males. Scandalous. Yeah. Shocking. Why do they do this? For fun.
This one.
No, I'm just kidding. They do this
To ensure that they get the best.
genetic diversity. Absolutely. And so we know that they'll go off and mate with a handful of other males for genetic diversity, but how does this process actually work? How do they select the best genes? Well, they're really smart. And in fact, just like humans, these females, they're much smarter than the men. What they can do is they have to remember lots of information. So these, oh my god, New Zealand eagle ray. Yeah, beautiful. Try to cruise back over him. And so the ladies, they have to memorize all of the characteristics of their partners, like their size, their coloration abilities, their intelligence, as well as the amount of zeros that they have in their bank accounts. And then with that information, she has to then make a critical decision. Which male she wants to fertilize her eggs with. And these ladies, they can actually choose to fertilize her eggs with a male or males of her choosing. So how does this work? Well, these males, the packets of genetic information, they're called spermatophores. And the spermatophores, they're individually wrapped. These separately sealed packets. And so she can choose to break open one or multiple packets and then fertilize her eggs with them. And she stores them. She's got this space. There's the right.
There it is.
She's got that space. It's located just at the base of her tentacles. Or just behind her tentacles. It's called her mantle cap. So she can store them there, and when she's ready to fertilize, she goes off and does it. Pretty amazing. They're really smart creatures. And another way that we can assess their intelligence, aside from the sneaking behavior and the mating behaviors, is feeding behaviors. So guys, when you travel to a new place, when you're on holiday somewhere, and you go to a new spot, you got an accommodation booked somewhere, you can start to get a feel for the neighborhood, right? You'll start to be able to make connections, figure out where something is in relation to each other, like where some shops might be or some restaurants might be in relation to certain places. So they can do the same thing. So geospatially, they can memorize where different sources of their food are, how much food is in a certain area, and then make decisions on where to put based off that information. More down there. Oh, some mating. There's some mating on the rocks. I'll try to cruise back over, guys. If you guys see any mating, please yell out. Okay? Some more mating. So guys, if you do see mating, yell out. Okay? Cuttlefish copulation takes roughly the same amount of time as human copulation. It's about 30 seconds. Had a pretty good stamina, if you ask me. Now, okay, there it is. There's the mating. There, under the rocks. Nice. See some more of that. It's been a pretty raunchy week, so I'm sure we will. Now, you guys know how you have food preferences and how I have food preferences? So there's pasta in there. For those of you who are wondering, my favorite food is Italian. Okay. But these guys, they do have food preferences as well. And remember, they only live to be 12 to 18 months. They have a short lifespan. And they go from this, so they can go from this big to this big, right? So they need to change the types of food that they eat as they grow and develop. So they're constantly changing what types of food they like to eat based off of what's most efficient for them. Pretty cool. Kind of amazing. Now these creatures, they are protected in the waters of the upper ventricle. But that didn't always used to be the case. So back in the late 90s, there was a fishing industry, export market, shipping them out to Portugal and Hong Kong. And in 1997, there was one fishing boat, and they were taking out about 2 tons per day. In the following year, there were 14 fishing boats taking out 2 tons per day. And so the upper ventricle cuttlefish population nearly got decimated. We went from having right around 200,000 on average, having less than 10,000 along the same kilometers of coast. And so there was a while, scientists didn't know if they were going to come back for a handful of years. So what happened was fisheries put in a temporary fishing ban, and we did get some sanctuary zones set up. So sanctuary zone is complete no-take zone for all fish species, just set up down the coast here a little bit. Due to the efforts of the local wildlife diving community, as well as some state and council government initiatives. And just in 2020 was the best year that we had. So we got back up to over 200,000 in 2020. And the populations, they do fluctuate. So like we're seeing a bit of a decline at the moment due to just natural environmental factors. Populations have been low, it's super normal. I think the report hasn't come out for this year, but we expect it to be kind of around that 150,000 mark. It was also a bit of a late season as well. We didn't start operating this vessel until the 3rd week of May, which normally we start in the 1st week of May. But yeah, so 2020 was a good year. They've all been good years sort of the past decade or so. And then just last year, we got what's known as heritage listing. And the heritage listing, it's great, it's fantastic. What this does now is nationally recognizes this site, this event, as a place of environmental, cultural, and ecological significance. And what this has now done from a federal government standpoint is set up all of the water from Arno Bay to Wallaroo in north as complete cuttlefish exclusion zone. And during the months between April and August, it's complete cephalopod exclusion zone. Which means you're not allowed to fish for squid up here either, or octopus. And the reason is for that is because right now, do we see any squid?
No.
Why? Well, squid like to eat the same things as cuttlefish. So they're all competing for the same food source, right? And so, right, you know, we expect that there's probably going to be 150,000 adult cuttlefish here, but how many eggs does the mother lay? Well, she lays a couple dozen, so anywhere from like 20 to 30. So it's not going to be 150,000 cuttlefish hatching. It's going to be over 1 million cuttlefish coming out, right? We don't know the exact numbers. That's something that hasn't been studied yet. Hopefully we get more crew like Bethany up on the tour, helping out and getting in the water and figuring these sort of things out. But yeah, there's going to be millions of baby cuttlefish that once they emerge, they're going to be voraciously feeding. And so the other species that will have to compete for food, they also will. And so right now it's a really good time, probably the best time that these cuttlefish have ever had. Or not ever had, but in the past few decades. It's a great time to be a cuttlefish, but the work's not done. The battle is it's not over. Why is that? Well, these populations, their populations, can still be impacted by environmental conditions put upon them by us. So guys, have a look in front of us. Have a look in front of the boat. What's that over there? It's an oil refinery. It's Big Daddy Santos over there. Big Daddy Santos, he's had a couple of the oil spills here. Yeah. And that's, we can't actually go up the jetty, but the reef that's right around the jetty doesn't look nice. It's not as healthy. So things like that.
That one's mine.
It's like a little bit of Manny going on. There we go. And then also behind us we got steel. So we're sort of bookended between a couple of the dirtiest industries on the planet. And with new and developing industries, not just existing ones, but new ones, like hydrogen moving into town. You guys know where they want to build the hydrogen plant?
Yeah.
1 kilometer from where you're sitting right now. All of the land just across the street from Cuttlefish Drive, the street that you turn down, come down here, all of that land is earmarked for the hydrogen plant. Now we need sustainable forms of energy. We need clean forms of energy. I'm all for that. But what do they need to fuel the hydrogen plant?
Water.
Water. Exactly. Right? Because they split. Oh, there's some more mating going on there. Sweet. Hello.
Oh, someone snuck in underneath there.
Oh.
There's your little one that snuck in underneath.
You'll see a little sneaky.
Yeah.
So these hydrogen plants that need water for clean energy, where do they get that water from?
To the sea.
They get it from the ocean. So they built these bits of infrastructure called desalination plants. They suck in seawater, separate the salt content from the water, pump, and then utilize the fresh water, and then they pump back in hypersaline water back into the ocean. So by changing the salinity content of these waters, it can definitely impact them. Now, during the wintertime, it shouldn't be too much of a problem because there's a good amount of water flow. But during the summertime, when there's less tidal movement, absolutely can definitely impact the salinity content. We've already established that it gets really hot, right? It gets up to 27 degrees up here. And so when it gets that hot, there's already more evaporation taking place, so the salinity content naturally goes higher during the summertime. And so if you change that too much, all of the algae and plants here that provide habitat for the critters that they like to eat will go away. So this site is heritage listing for the cuttlefish, but what you're looking at, the habitat that we're cruising over today, that you're looking at right now, is not regulated. None of this is protected. Yep. Now, I know it's a bit of a double-edged sword. I want protections. The owner of this business wants more protections put in place. And if that's the case, then and we can't do this. Talking about the environmental impact of the vessel. What sort of impact are we having on these guys right now? Well, we're seeing these cuttlefish, they're not changing color, they're sort of remaining really stable. So let's ask ourselves, what does a scared cuttlefish look like? What is one that's afraid? What do they do when they're afraid? They hide. Right? So, if they're afraid, oh, that is a big question. So when they're afraid, they'll hide. And do we see them? I know some of them are camouflage, but are these guys getting afraid when we cruise over them? No. Now, does the sound of the engine bother them? Not really. They're staying in one place. The one thing that this could impact, the sound of the engine could impact, is their feeding behavior. So, we're talking about how do they locate food? Well, they will actually use the sounds of snapping shrimp. So if you jump in the water, you can hear a crackling sound. If you're jumping snorkeling on a healthy reef, you'll hear it sound like a popping, crackling sound. It's really loud. And so they'll use the sound of snapping shrimp to locate the sources of their food. So the sound of the engine could definitely do that. If you do that, some more mating in the middle there.
Yep.
Nice.
Look at them all.
But are they feeding during the summer?
No.
No. So they're not going for food. And we don't operate the boat when the hatchlings emerge, when the hatchlings are, when they're going for food. So it does have a pretty minimal impact. I can't imagine that yeah. Now, thankfully, these industries, the hydrogen plant and building desalination plants, and these existing industries, they're having to be really careful. And they're taking precautionary measures because of you guys. By you coming out today, putting your butt on the boat, putting your eyeballs on the cuttlefish, learning about our marine ecosystems, and about cuttlefish, we're getting more protection than there's ever been. The government is having to be more careful. These industries are having to be careful. We're getting more support in the forms of like funding for research, getting people like Manny down so they do this sort of stuff, figuring out where they're going, as well as, you know, a bit of developments for the site, make things a little bit nicer for us when we have to see it. So, thank you, we appreciate it. And it's not enough, because these guys, these creatures, they have a really important role in the ecosystem. They've got a really important job. Let's ask yourself, what is their purpose? Can anybody take a guess? What ecological niche do they fill? They're a really important part of the food system. Right in the middle of what we call the food web. And these guys, their job, their role, is to help maintain, keep in check all of the baseline food chain species that exist here. And to understand why that's important, we need to understand fundamentally what this ecosystem is first. So all this stuff that we're cruising over, there's the ray in the middle, towards the front. Dylan? Yeah, I'll try to get back over it. He likes to do it. So, probably be cruising up the middle for 10 seconds. You guys see the ray still? Here he is. Here's the ray, friends. So talking about this ecosystem, what is this ecosystem? What are we looking at besides the cuttlefish? What is all this stuff? Well, it's algae and seaweed. What is it? Well, what would you call an aggregation of trees?
Forest.
That's what this is. This is a forest. We're looking at an underwater forest right now. And I call it a forest for a few different reasons. These plants, there's sunlight beating down on them. These guys are photosynthesizers, just like terrestrial plants. What do photosynthesizing plants do? They make oxygen. There you go. Now, here's another question for you. What percentage of the planet is covered in ocean? 70%. Guys, where do you think most of the oxygen we breathe comes from?
In the ocean.
It comes from the ocean. It comes from ecosystems like this. And these plants, they're not just really good at producing oxygen, they're also really good at capturing carbon, removing excess carbon dioxide from our atmospheres. They're carbon sinks. Now the second reason that I call this a forest is because this stuff, just like a terrestrial forest, provides habitat for the creatures that live here. And giving housing, homes to all the little creatures. And the third reason I call it a forest is because you know how trees produce sap? You get maples here, maple trees.
Yep.
Yeah. This stuff also produces sap. And sap is a slimy substance. It's chock full of nutrients. The things here like to eat it. Now, a lot of these saps, these algae, they actually are edible to humans. I've tried a bunch of them. Most of them are nasty. Take my word for it. But the things here, they like to eat it. And so let's ask ourselves, what would happen if we removed the cuttlefish from the ecosystem? Well, these baseline food chain species, these little critters, it's in their nature to eat this algae. So what they would do is they would eventually wipe out this forest, right? Which also acts as habitat for the kingfish and the snapper. Right? So these are all, it would upset the ecosystem. Right? Now, how do we know this? You're probably thinking, Manny, that's pretty crazy talk. But we've seen it happen before. And that actually happened in my hometown. So in California, we have these things called sea otters. Sea otters, they're like aquatic ferrets, they're really cute. And sea otters, they eat sea urchins, those black spiky balls we see beneath us.
Yeah.
And sea urchins, I know they seem stationary, but they do actually move. And sea urchins, they eat the roots, the bases of giant kelp. And so, just like the cuttlefish, we hunted out the sea otters. They're now an endangered species because of us. And what we saw happen was a domino effect. We lost the sea otters, the urchins spread out like crazy, and they wiped out our kelp forests. They destroyed the majority of the biomass of our Southern Californian kelp forests. Which those kelp forests are homes to the giant sea snails. So now we're starting to see this domino effect where we lost the kelp forests, we're starting to lose these other really keystone species in our ecosystems. And so we'd see a similar thing happen here. Because these creatures, these cuttlefish, they're not just important for maintaining this ecosystem. And because they maintain the ecosystem, I like to think of them sort of like the park rangers. Doing burn-offs and making sure everything's running smoothly, right? But these guys are not just the park rangers in this forest. They also have another really important purpose. So these guys help maintain populations, help sustain populations, I should say, of species higher than them in the food chain. So, who here has seen an Australian sea lion? Australian sea lions? See them? You're very lucky. You know why? Just like the otters and the cuttlefish, we hunted them. They're now an endangered species. There's only about 10,000 of them left in Australia, between SA and WA, and SA has about 80% of the population. Now, the Australian sea lions, they've been protected for a few decades, but we were still seeing their numbers decrease at a rate of about 2% per year. Now, it just so happens that my neighbor, he's the sea lion guy, he works for national parks. It's his job to go and survey all the sea lions around the state. He was telling me just before I came up here this season that he believes, based on recent research not quite published yet, which will hopefully come out later this year, that the sea lion populations, they're starting to stabilize. Sea lions are making a comeback. Epic. Really good to hear. And it's important to understand that correlation does not prove causation. Just because something is happening in the ecosystem doesn't necessarily mean it's caused by something else. Right? So it's just a theory. But when you look at the statistics, when we look at the numbers, and you compare the populations over the years, you can see there's a direct correlation between the recovery of the cuttlefish populations and the now recovery of the sea lion populations. So they go hand in hand, right? So by having a consistent and stable food source, other animals are now doing better. So not just for their sake, not just for the cuttlefish' sake, but also for our sake, we should be doing our best to try to keep these guys around, keep them healthy, keep their populations up, and protect these ecosystems. It's really important. So guys, does anybody have any other questions about the cuttlefish or about our ecosystems on the Great Southern Reef? What's that?
You covered it pretty well.
Yeah. Yes. So they would be very distantly related. Yeah. Now, so we have about, within South Australia, we have about 8 or 9 different species of cuttlefish. Species of cuttlefish. Within Australia, we have about 120 different species of cuttlefish. So we have a bunch of different species. And cephalopods as a whole, we have over 300 species of cephalopods, including squid and octopus. They're all sort of related. There are commercial fisheries for certain ones. But yeah. But talking about the reproductive strategies, like certain cephalopod species are sustainable to fish. Now, what do I mean by that? Well, when you look at the squid, for instance, has anybody ever seen a bundle of squid eggs in the wild? So, sir, what does it look like?
White, yellow, just little balls.
So it's like these little balls, right? And the ones we have here, the southern calamari, they'll lay these big bundles. It almost looks like a bundle of grapes, right?
Yeah.
These white, sort of elongated grapes. And they'll lay a big bundle. And they lay their eggs. They'll try to put it in a sort of a protected bag, but they'll lay them on top of the seaweed, and they'll have hundreds of eggs. Now, they'll have a higher mortality rate, but because there's more babies being produced, there's larger populations, whereas species like this, that only lay a couple dozen eggs throughout their entire lifetime, they're much more susceptible to to becoming endangered, right? So, in certain species like octopus as well, octopus will lay a couple dozen eggs, but they're pretty good. Like octopus, because they lay their eggs in a protected space, and the mothers, they'll actually use their bodies to protect their eggs, and their bodies will be consumed by their young. They'll be the initial food source for the babies when they pass. It's just like the cuttlefish, the squid, and the octopus. They only live for about a year as well. So it's a really short lifespan. And because of that, octopus populations are really, really high. You can find octopus pretty much all over the world. Every single continent. They're highly adaptable. Octopus are more adaptable than species like cuttlefish. So, like eating octopus or eating squid is more sustainable than eating cuttlefish. But yeah, definitely trying to be mindful. Like, I do eat seafood, but I always try to eat local seafood. Stuff that's sustainably fished. I live in California Bay, and there's a lot of oysters down there, so most of the seafood I'm eating is farm. And so if you're looking for sustainable seafoods, there's a few different websites, some sources about where to get sustainable seafood. Like different restaurants that'll put that information out. So there's a few different ones. I think cleanseafood.org is a really good one. Anyways, guys, if you've had a good time today and you want to do your part to assist with the conservation and protection of these amazing creatures, tell your friends. The more people that we can reach, the more we can educate people, and the more awareness that we can raise, the more good we can do for these environments. So tell your friends, feel free any photos or anything like that. Feel free to post them on Facebook and Instagram. And also by leaving a review, that really helps us out as well. We're on Google reviews and TripAdvisor, all that sort of stuff. And my wife, she loves it when I get name dropped. So my name is Manny, with 2 N's and a Y. Now, if you guys had a bad time today, my name is Marley. Yes, we'll be in just a moment. Give me a slight bump of wings. The tide is pushing us on. And you guys, if you're hanging around Willa, looking for some fun things to see or do, definitely go check out the Maritime Museum. It's today's Wednesday? It should be open. Is that tours? So the Maritime Museum, they used to build big ships here back in the day.
Manny.
And yeah, that's really cool.